Getting started with serverless. Live demo with Apache OpenWhisk with Upkar leader.
All right, so yeah, thank you for having me today. I'm very excited to talk to everybody about serverless. Where is everybody coming from? So as Brian said, I live in the Bay Area. I live in San Francisco. It's nice and sunny here for a change. But I'm curious to know where folks are coming from. Florida, nice, nice. North Carolina, I've never been. Portland, oh my God, one of my favorite cities. Very cool. All right, all over the place. Ghana, wow. I will, Heather. Thank you. All right, so thank you for doing this. I like to keep my sessions very interactive. So, as Brian said, if you have any questions, there's an ask a question button. Please use that to ask any questions. We'll go through that during the talk. Costa Rica, thank you, Danny. I hope I said that right. Cool. And then my second question to you is like, what has your experience been with serverless? So if you can answer, new versus, used in production versus side project. I'm really curious to know what the experience has been. Okay, it's pretty new. Okay, new. Heather's new. Greg, new. Okay, well, that's great. This is an intro session, so hopefully I will not be boring anybody with this. And if you have experience with serverless, or if you're a master, I do have some exercises and labs you can try on your own, and that way, hopefully, even if you know serverless, you get to try a new product. So the product I'm using today, let me go to my slides real quick. Thank you for chatting with me and answering these questions. It's very helpful. So the title is a little bit misleading. This is obviously a talk on serverless. I'm working with Brian. We're working to bring you a longer serverless workshop where you can actually get hands-on and try a couple of serverless concepts. But more importantly, the serverless, the principles we'll talk about today, the concepts we'll talk about today apply to various different platforms and distributions that you see out in the market. But I always like to use a specific, concrete code examples to show the different features of serverless. And I've picked Apache OpenWhisk, which is an open source distributed serverless platform, to showcase some of these features. Okay, so we'll talk about that in a little bit. We have about an hour, and Brian said usually, leave some time for Q&A, so we'll do that. A couple of links here. So I've got my Twitter here. Please, ask any questions that you may have here, or if you have questions later, please do ping me on Twitter. I'm quite active there. I also have my email listed here. If you have, if you need to talk in more detail, please do email me. There's a link for IBM Cloud signup. So I do work for IBM, and so this is my sort of mandatory plug here. I will show you some of the IBM Cloud today as well. And then when we do the workshops, we'll use the IBM CLI, which is the command line interface, and a plugin to do a lot of this serverless stuff. The cool thing is IBM is one of the core contributors to Apache OpenWhisk. And in fact, our production level cloud functions solution is based on Apache OpenWhisk. And again, I'll show you that in a little bit. All right, so for people or for folks who are new to serverless, there is no magic here, right? So I found this on this site down here, and the cartoon basically is saying there is no serverless with a crying face. It's just somebody else's container, which is very true. And if it's not a container, it might be another sort of runtime platform. So basically the idea is it's not magic. You still have servers, but the idea now is that you don't have to actively manage these servers. So this is a longer definition that's coming from the Cloud Native Computing Foundation. And I've put a link at the bottom. If you want to learn more, this is from a white paper they have. I believe as software engineers, you have to keep up to date with these different pieces of technology, and one really good way to do that is to read research papers or academia, as well as of course documentations, API docs, etc. So this is a good white paper on serverless computing, what that means, its role in the bigger cloud native space. So feel free to read this. It makes for good bedtime reading. But the concept again is that you as a software developer are no longer required to do server management and maintenance, right? So your code is bundled as one or more functions, they call it. You may have heard the term actions or Lambda, and then they're uploaded to a cloud platform. And then more importantly, they're executed, scaled, and built in response to exact demand. So it scales down to zero when you're not using it, and it goes up to as high as your usage goes. And consumers of serverless computing, which might be us as developers, we no longer need to spend time and resources on server provisioning, maintenance, updates, scaling, etc. All of that has been abstracted away from us as developers. Now, I don't know if you remember, but not too long ago, if I wanted a site up and running, I had to go ask for a virtual image or a VM of some sort. I had to decide how many CPUs I want. I had to decide how much memory I want on it. And that required some capacity planning and looking into the future and deciding what kind of traffic I might get on my site. So with this new paradigm, some of that has been abstracted away, or not abstracted away and also automated for you. Okay, so that essentially is a broader definition of what serverless means. And then also I've seen quite a few use cases for serverless. The first one is to create secure and scalable APIs. So a lot of these serverless platforms come with some sort of API gateway. So essentially what you do is you create your function or your action, which is your code, and then you put it behind some sort of API gateway that then gives you some endpoints that your consumers can use and other applications can use, as well as gives you other features like rate limiting perhaps, or additional authentication. What this provides for you, if you're doing think of a typical REST API for a given resource, wherein every one of those, CRUD APIs or endpoints are a function. So you have a function to create a resource, a function to read, a function to delete, update, post, etc. And now what you get is HTTP level scaling, because each one of those functions can be scaled up or scaled down to zero based on how they're being used. So I think that's a pretty cool concept. Versus having a single ExpressJS app or Django app or Flask app that has the 4 endpoints as part of a single application. Now, sure, you can break that up into microservices as well, but this is one of the use cases I've seen with the whole serverless solution. The second one is creating some sort of microservices or backend services. So your service is doing one thing and it's independent of other services. It might be getting input from other services and sending output to some other services, but essentially it is isolated and does one thing. And that is a good use case, might be a good use case to put that quick running service on a serverless platform. And one of the side sort of bonuses you get with that is you can get polyglot functions. Now, not a lot of people do this, but I have, as part of my job, I go to hackathons and meetups where I'm mentoring maybe college students, right? And a lot of times when they form teams, the first question is, what framework should we use? Should we use a Python-based framework or JavaScript-based framework? And my answer to them is, well, use all of them. So if you divide your problem or your solution into multiple functions that depend on each other but are isolated and can be tested by themselves, then perhaps you can write one function in Python, one in JavaScript, and something else in perhaps Swift or something, whatever you want to use, and they can all call each other, or perhaps use a central message hub of some sort to communicate with each other. And that way, you can have your team members program in the language they're most proficient in, and yet be able to build this end-to-end solution for your hackathon. The example shown in this picture is, in this diagram, is somebody's uploading a set of pictures to a database, which triggers a function, and that function then processes the pictures. So it might be doing some image analysis, some visual recognition, maybe object detection, identification, or it might be converting the pictures into a different size. It might be converting the pictures into grayscale. Whatever logic or processing needs to happen happens in your function or in your action, which is living on a serverless platform. And the result you get, you either get back as a JSON, or perhaps it's stored in another database after processing. The third and final use case I've seen with serverless is event-driven programming, and that's that goes along with keeping all of these different services independent of each other. And so in this case, there is data coming into the second icon here is the Kafka message hub. So some application, some user, some event is triggering or putting a message onto a Kafka message hub, which then triggers a function. So that's an external event that's happening, which is triggering a function. And this function, in this case, maybe is taking some of that information, processing it, and storing it into a database. But as you can imagine, you can do whatever you like once the message comes into a queue. But the idea is that you are, less or you're loosely coupled and more event-driven than versus being tightly coupled to external events. Okay, and there are some examples of these that I'll show. I'll quickly go back to. I'm looking for questions. I don't see any yet. Okay. All right. So those are some of the use cases. As you can probably imagine, based on those use cases, this whole serverless paradigm, or creating serverless functions or actions, it leans very well to small, focused, independent units of work. So if you can break down your problem into multiple small problems or small solutions that can be run asynchronously, concurrently, and easy to parallelize, then you can imagine, serverless might be a good option, because you can spin up multiple of these containers to run your functions or your actions in parallel. The second point here is if you're not sure of your demand, so your demand is unpredictable, in which then results in you're not sure of capacity planning, you're not sure of scaling requirements, then again, serverless might be something you want to take a look at, because of how dynamic it is, of how it can go up and down in usage as demand varies. Traditionally, serverless platforms are stateless, and so if the caveat here is it is your responsibility as a developer or as a consumer of the serverless platform to then be able to maintain the state outside of these actions. Because remember, these actions are spinning up containers, and then once the action is done running, that container may go, maybe deleted, or maybe stopped, or maybe paused, and then you have no access to it. So that's something to keep in mind. Here's a very simple, sort of naive example. Let's say you have a conference app, and you have a service running on this conference app that brings up, the different talks in the conference. As you can imagine, if the conference is running for a whole week, there's a lot of demand on Monday. People are excited when they wake up, and they want to see what's going on. We all sign up for our favorite talks, our favorite speakers, and then during the day, maybe at lunchtime, the demand goes down a little bit. And by the end of the day, people are not on the app as much as they were in the beginning of the day. Not only that, the usage goes down over time. And in this, again, very simple example, what it's trying to say is, for the parts in red where the service or your app is not being used as much, then you don't want to pay the same amount as you were paying when the app was being used at full capacity. So this is where everything is sort of on demand, and you pay for what you use. All right, at this point, I do want to show this really cool open source repository of content that IBM has provided to our community of developers. And so if you go to developer.ibm.com, again, not just because this is IBM and I work for IBM, but I really think this is very helpful thing they're doing for developers. So if you go to this developer.ibm.com, there's something called patterns. Let me see. Well, I could look at these patterns through different technologies. So let's see. But what I want to do is I want to come down to this section called code patterns. If I say view all code patterns, which, by the way, takes you to this site. So I'm just going to paste this here, just for your reference. But essentially, code patterns are end-to-end solution. It comes with a lot of assets, including maybe some. There's a GitHub repo. There's a lot of code. There might be a video explaining what's going on. And depending on what topic you're interested in, so let's say if I go down here, and since you're talking serverless today, I will pick serverless to filter out my code patterns. As you can see, there's tons of code patterns on serverless. This one is interesting. So this is deploying a Alexa skill with serverless. There's stuff on processing images. So actually, let's take a look at this one, right? So this is serverless image processing. This is a scenario that I went through before. But in this case, what's happening is if I go down, there's usually some sort of flow, right? So in this case, a user comes into the browser, uses a web application, which triggers, they upload a picture to Cloud Object Store. So Cloud Object Store is, it's IBM's S3 compatible version of Cloud Object Store. Once an image is uploaded to Cloud Object Store, it fires a couple of triggers. In this case, it fires two different functions. The first function converts that image into grayscale, and the second function uses visual recognition to figure out what's in the image, and then the result is given back to the user. So, this is a very simple example. It's using serverless, obviously, and this is one use case I talked about before. So you can click on Get the Code to go to the GitHub repo to see what's going on. And this is where I think it's really cool. You can actually, it tells you how to deploy this locally on your laptop and also to IBM Cloud. And essentially, what this consists of is getting some sort of API keys from different services on IBM Cloud, plugging them into the right place, and then following these steps, and you'll have this application up and running on your machine. And these are, again, all open source. You can learn from this or even use this for your own applications. So anyways, there's a lot of different patterns. We won't go into all of them. I just wanted to give you this resource for later. Okay, that being said, folks also ask me about the different players involved in the serverless landscape, and there's quite a few. And again, this is coming from the Cloud Native Computing Foundation website. If you want to know more, you can go to the site and you can hover over any one of these icons, and it tells you more about how this company or the solution that the company provides. So if you see at the bottom here, the bottom row is the installable platform, which means you can take this. They're usually open source. You can take it and install it on your machine or in your cloud. The second layer is the hosted versions, and this is where somebody else is managing the serverless infrastructure, and you're using that as a consumer. And then, of course, like everything else, people have built abstractions on top of these platforms. There's a whole security layer, and other tooling that you can put on top of these different serverless installable or hosted platforms. So all the way bottom here, you see Apache OpenWhisk, and then up here is the hosted version of Apache OpenWhisk, which is IBM Cloud Functions. Another very common question I get is, which one is better? Is Amazon Lambda better, or Azure, or Google Cloud Function, or IBM Cloud Function? Again, this space is constantly changing, and so you really have to go try it out and see which one works for your specific use case. The good news is pretty much everybody makes it really easy to get started, so it's easy enough and free to try these things. And of course, I'll show you IBM Cloud Functions and how easy it is to get started with that. Speaking of, so Apache OpenWhisk, as I said before, it's an open source distributed serverless platform system or platform. And essentially, to use Apache OpenWhisk, to get started, you need to have a good understanding of three things. So one is an action, which is your code that you're trying to deploy and scale online or on some cloud. The second one is a trigger, and essentially trigger is waiting for an event from an external source to occur, and then it fires, or the platform fires that trigger if that event happens. And triggers and actions are connected to each other with something called rules. Okay, and I'll give you a couple of examples shortly. But here is a list of contributors to Apache OpenWhisk. IBM, like I said, is a core contributor. Um, the solution was conceived at IBM Research, and then Red Hat, Adobe, or some of the other bigger companies that joined this effort. So here's a couple of examples, right? So like I said, action is your code that you're deploying online on IBM Cloud or on another hosted version of Apache OpenWhisk or your own version of Apache OpenWhisk. It supports a number of different platforms. This slide is a little bit older. I need to change it. But essentially, you hopefully you see a language or a / runtime that you're familiar with or like to use. If don't, that is not a problem as well. Docker is a supported runtime here, as you can see. So as long as your runtime or your platform or your language runs inside of Docker, then there is a way to use that as a runtime for on Apache OpenWhisk. So this Docker tile basically opens up possibilities to do a lot more than the languages listed here. So that's your action. And then, like I said, trigger is something that's waiting for an external events to happen. And what kind of events can you react to? Well, there's a number of them. This is just a subset. So for example, people have built triggers for social events. So Git is an example. So if there is a pull request or if there is a new commit, then you might want to trigger an action that does something. Slack is another one, and I used this in the last hackathon I was at in University of San Jose, and essentially we built this bot on Slack which waits for message to come in on a channel and then triggers a function that uses NLP to figure out the rudeness of the comment, and if the comment is rude, then the bot basically goes back to that to whoever's posted it and tells them to be polite and something like that. So it was pretty successful, and also a good experiment to run at the hackathon. The other kinds of events, data changes, like I mentioned before, if somebody's a use case might be somebody uploads a picture and that triggers some sort of processing on the picture, and so the event would be a database change or a record change. Device readings with IoT, with variables, there is tons and tons of data coming in, and you may want to use a serverless function perhaps to process that data or to summarize that data. You have to be a little bit careful with that, because with serverless, you're being charged with perhaps the number of calls that are being made, and so or how long it's running or how much memory it's using. So based on the IoT stuff, there's usually tons and tons of calls that come in. So it's better to use, IBM has a platform for IoT, better to use something like that, and then pass the summarized version of your data to a serverless function rather than passing in the raw input that comes in, perhaps. User input is another interesting one. This could be as simple as somebody using the phone to enter some information, or somebody using a simple HTML form. And then when they hit submit, instead of having a complete Express.js web app that processes that input, maybe you call a serverless function that processes that input. Okay, and location updates, put that with the device readings as in the IoT bucket. So you have all these different kinds of events that can trigger, that can fire a trigger, right? And then you have all these actions, and the way to link the two is with a rule. So rule is simply linking a trigger to an action, right? And the reason for making each of these separate is each of them action trigger rules are sort of first-class citizens. So you can have a trigger, you can have rules that connect triggers to multiple actions, and that's the link. So for example, when the image was uploaded to the database, there was a rule that connected that to the action that processes the image. Okay, so those are the three pieces. The fourth one down here is called a package, and that's how you put your actions, triggers, and rules together in a module. And now that becomes shareable. You can share it with your team, or put it in the community packages on Apache OpenWhisk, so other people can now use your package. All right, I'm going to pause there for a second and go look at questions. Still no questions. Okay, no problem. All right, don't reach too much into this slide. Essentially, this goes behind sort of OpenWhisk and shows you the different pieces. So there's an Nginx server that receives all the requests and then forwards them onto this controller. Controller is the only sort of custom piece in this big picture. And controller does a couple of things. So it'll do authentication, authorization, and then it'll also do some sort of scheduling. But then it sends off whatever request has come in into a Kafka message hub, which then the controller then runs the right invoker. Invoker are your Docker runtimes. Docker is just one example, but these are your runtimes that will run your action. CouchDB is the database of choice here. CouchDB is a NoSQL document-based open source database. And so that's used for for storing your credentials, as well as storing all of the actions. Your code that runs on serverless platform also sits inside CouchDB. So again, there's a lot more to it. And again, it's all open source, so you can actually go and take a look at how the controller is implemented, how the scheduler is implemented. It's written in Scala. So another good way to learn a new language is actually to go and explore how OpenWhisk works under the hood if you don't know Scala. But the point I'm trying to get across with this slide and the next one is OpenWhisk leverages a lot of existing open source solutions. So it's built on very solid foundations. Okay. This is, I installed OpenWhisk locally on my laptop, and I got a bunch of containers. So as you can see, a bunch of images. There's a couple of Node.js, and this is old, so that's why it says Node.js 6 runtimes that were made available to me to run JavaScript actions. There's the API gateway, there's the controller, the set of invokers. So this is essentially the picture I showed you before, but I guess I'm validating that this is actually what's happening behind the scenes. And so you get a bunch of images and containers like this. And then you also get a very robust CLI. So it's called WSK CLI, or Whisk command line interface. And this lets you work with actions, packages, rules, triggers, things that we just looked at, and other things as well. And the cool thing with this CLI is that the help, the help is provided within the CLI. So if I just say Whisk action, it tells me everything I can do with an action. So I can create an action, update an action, invoke an action, which is actually run an action, or I can get the details for the action, I can delete an action, or I can list all of the actions in my namespace, right? So very handy CLI. What I'll show you today is IBM Cloud CLI, which builds on top of this Whisk CLI. Now, there are quite a few built-in packages on Apache OpenWhisk. I've listed some of them here. They're all under the whisk.system namespace. So as you can see, there is the Slack package. Again, this will listen to messages coming into a particular channel. You can also use this package to send message to a Slack channel. And there are quite a few other ones as well. You can do a get command. So you can say, hey, Whisk, get me the details of this package, the weather package, under whisk.system namespace, and only show me the summary. So that's the -- summary flag. And as you can see here, it comes back with the package details. And in this case, there's just one action in this package, which I can call. And this is the forecast action. And it gives me the 10-day forecast given a specific latitude and longitude. Okay, so these are the parameters that the action takes. This is for the same command. So get me a summary of everything inside the cloud whisk.system/cloudin package. And this is Cloudin is the hosted or managed version of CouchDB on IBM Cloud. So this is a NoSQL database. In this case, you can see there's a ton more actions. I've only listed some of them here, so you can work with documents, attachments, etc. But at the end here, there is something called a feed. And that's what I use to create a trigger. So if I create a trigger in my OpenWhisk platform or my solution or in my package and link it to this feed, every time there is a change to the database, and which database I specify using this DB name parameter. So I say, hey, whenever this one database changes, then let me know. And so what that does is whenever the database changes, it fires my trigger, which is attached to this feed. And if my trigger is attached to some action using a rule, then the action gets fired as well. Okay, so hopefully that made sense. No questions yet. Everybody's being really quiet, so I'm going to assume everything's making sense. All right, so this is how you create an action. So actually, you know what? I'm going to skip some of this and actually show you some code. Before I do that, just one more thing. There are some rules you have to follow for each one of the, not just IBM Cloud Functions, but for other platforms as well. So this is what makes a valid action on Apache OpenWhisk. So in this case, you need to have a entry point, have an entry point into your action, which in this case, it's a function called main. In JavaScript, if you're doing Node.js runtime or JavaScript actions, your function or your entry point needs to have a parameter, or it needs to have an object as an input and needs to output an object. This is a simple use case, okay? And then to create that action, you just use, again, the CLI to create the action called hello.js. You tell it where the source is coming from, and then what kind of action you want. So in this case, I'm asking for a Node.js 10 runtime. I could have left that blank, in which case it picks up the runtime based on the file extension. Okay, so let's actually see this running. Thank you, Henry. All right, cool. So I have an empty directory here. Oh, it's not empty. Let me remove that. So there's nothing in this directory, as you can see. I'm going to write a new file called index.js, and then let's work on this file. So I'm going to open VS Code. It's my favorite editor. So as you can see here, let me close a bunch of these. Don't save. And let's close this. All right, so I have VS Code editor. There's nothing in here. So I'm going to write a function called main, and it takes in an object. Oops. Takes in an object. And then remember what I said, your function has to return an object. So what I'll do is, if params exists and has, oops, I didn't want to do that. Params.name has an object called name. In this case, I'll say return a message of hello to the name. So I'll say hello, and I'm using this string interpolation in JavaScript to say return params.name as a string, and then assign it to the message attribute of this object, which is what I'm returning. So I have a main function, takes in an object, and returns an object. If name is not present, then I want to return, oops, a message with just hello world. Okay, so fairly simple. Let's format. It looks a little bit nicer. So this is my very simple function, right? So in this case, if I actually put, output that, this is my function. Let's see if this is going to run. Did anybody find an error? Nope. Usually, if there's a typo, people let me know. But maybe this will work just fine. So I can use this WSK CLI. But in this case, I'm going to use something called IBM Cloud CLI. Now, if I just type IBM Cloud and press enter, it tells me different things I can do with IBM Cloud CLI. And there's tons of things I can do with IBM Cloud CLI. What I'm interested in is working with functions or IBM Cloud Functions. So to do that, I have to use this plugin called FN on top of my CLI. And if I hit enter now, it tells me everything I can do with IBM Cloud Functions. So as you can see, I can work with actions, I can work with package, trigger, rule, etc. We haven't talked about activation, but essentially everything you do, every function you call gets an activation ID. And you can use that to later on go into CouchDB and look up what happened. And again, I'll show you an example. All right, so we have our index.js file. Let's throw that up to IBM Cloud as an action. So IBM Cloud Function, that's my plugin. I want to work with action. I want to create an action. I want to call it hello action. And then I want to tell it where to get the source from. The source is coming from index.js. And if I hit enter, this created an action on IBM Cloud, or your version of OpenWhisk, whatever you might be using, called hello action. If I were to do IBM Cloud FN again action, but instead of creating, I want to list all of my actions in the system. You'll see hello action is now one of the actions under this namespace, which happens to be just my email account, with the devs namespace. Okay, and it tells me this is using Node.js 10, or it'll be run on a Node.js 10 runtime. How do I run it? So I go IBM Cloud Function, action invoke. Okay, so invoking this action, I'm going to call it hello-action. Now I told you it'd be about activation ID, so this thing came back with this activation ID. I didn't get a result back. Now I can say, hey, IBM Cloud Function plugin, I want to work with activation. I want to get an activation, get me the details of this activation ID, hit enter. It comes back with this JSON. As you can see here, it's got information about my namespace, what my action was, or what this activation ID is linked to. It's linked to this hello action. And it took 39 milliseconds to run this code. I got a status of success. My result was this message of hello world. Remember, that's what our code said. And it gives me some other default values, so I can, I'm going to ignore that for now. Now, if I wanted to see this, the result come back and not use the activation ID to go look it up, I can use this -R, which means wait for the result to come back. So in this case, instead of getting back an activation ID, I got this hello world. So this was our first very simple hello world action that we deployed on IBM Cloud as a serverless action. Okay, so hopefully that was easy to understand. And now what I'm going to show you is real quick. If I want to pass in a parameter of name, remember it's expecting a name. I'm going to give it my own name. Then it says hello to that name, right? So that's easy. Another cool thing that I like to do is let me open this tab at the bottom, and I'm going to say IBM Cloud FN activation poll. And this is like if you ever deployed anything on a remote server. I remember back in the day, using tail to tail my remote SSH and then tail my log files to see what's going on. This is very similar to that. So if I run that command again, you'll see the bottom screen change. And this is, it said, hey, hello action was called. This is the activation ID, but no logs were produced, right? So to add logging to our system, essentially, it's just like logging in JavaScript. I'll just console.log this exact thing, right? And I'll say console.log. I know I'm repeating some code here, which is not the best practice, but this is probably the easiest way to show it. So I'm logging something and returning the same thing. Now I've changed my code. In order to update this action, again, it's really simple. IBM Cloud action, instead of create, I use this update. And I say, hey, update this action and use the same code in the source file. Great, my action is updated. And at this point, if I run the same command again, if you watch the bottom screen, it should this time, at this point, console.log. Right, so now you see this standard output to my console of what happened. So I find this very useful. It only goes up to a certain point, right? So as you can imagine, if you have 100 different actions running in your application in the same namespace, this tailing the logs then doesn't work, right? Because then this gets triggered left and right based on what actions are being triggered. So in that case, I would use something else. IBM Cloud Functions support logDNA, which gives you a really good, easy way to look at your logs as they come through, and you can filter and you can search and do all sorts of things. So that might be a better way to go. But for development purposes, I think this is good enough, and it's kind of cool to see the results right away as they happen. All right, I'm going to check one more time for questions. No questions. Okay, so one last thing I want to show you. So this is cool. We created this one action. It doesn't do much. It returns back a greeting, but that's just then that's your code. You can replace that with whatever code you want. People ask me about asynchronous functions. So if your function is waiting, needs to wait for something to happen, and then can you work with promises or async await? And you absolutely can. So what I'll do is I'll create another file called index async.js and quickly show you how that works. So it's the same thing. You have to have a entry point. In this case, it's main. And you have to pass in a parameter or an object as a parameter. And in this case, you can actually return a promise. I'll quickly write this up. So it takes two functions, resolve and reject, and then based on what happens here. So in this case, I'll say if params contains the name attribute, then I want to reject I want to resolve. So that's my success condition with a message saying hello to the name. Otherwise, maybe I want to reject saying must have a name. So I do need this, and I think this is good to go. Can we find any bug here? All right, cool. So I'm returning a new promise, which takes in resolve and reject. If the params has a name, I want to resolve. Now, this is where instead of doing something simple like this is where you would have a long-running operation, and based on the result of that operation, maybe you resolve and reject, right? So this is just using the asynchronous stuff. So let's see if this works. So IBM Cloud FN action, I want to create a new action. I want to call it hello. Again, let's call it hello action async this time. And it's getting all the source code from async from this index.async.js. So I've created my action, and now to use it, let's see if this will work. Live coding is always fun. I'm saying call this action. So in this case, it rejected my promise. It said must have a name. And if I run that again with a name, so -p means pass in a parameter, call name. Again, I'll pass in my name. In this case, it gives me hello with my name, so my promise has been resolved. Okay, so this is the other way to do JavaScript. Now, Python and Go and Swift, all of those languages have their own sort of rules that you need to follow to create an action. And the last thing I want to show here real quick, and then we'll go back to the slides, is this is great. I have an action running. Now, how do I share this with my friends? There are two ways to do that. One is to convert this action into something called a web action. And the thing that you get with web action is you get a URL that you can share with other people. There are other things that happen. Web actions are really cool, and don't have time to go through them today, but we'll go through them in the workshop when we do that. But for now, I'll show you how to convert this action into a web action. And essentially, what you have to do is update something. Update this action and --web true. Oops. Oh, sorry. I meant to type in update, not Upkar. All right, so in this case, it updated my action to be a web action. And now if I say IBM Cloud action get, so get me the details of this action. And specifically, I want the URL. I get this URL. Now what I can do is I can go to a web browser and put in the URL. And you see now this action is accessible from anywhere. So I can say question mark name equals Upkar. In this case, well, I didn't need the quotations. Let me remove that. So in this case, you see it says hello Upkar. So it's the same action. Now I've made it a web action. Web action does a bunch of other things, which again, like I said, we'll go through in the workshop. All right, cool. So that was a very, very quick intro to how do you create these actions really quickly and deploy them on OpenWhisk. And going back to our slides then, there's a lot more information here that you can read later. I have some examples on what you can do, what more you can do. There's this whole concept of compositions in the serverless world where you're creating higher level actions from these lower level actions. And so your actions are treated as a first-class citizen. In this case, I'm saying, hey, composer, if create this authenticate action, and if the authenticate action is ran with a password of ABC123, then create the success action, otherwise create a failure action. So you can see within a single piece of code, I'm now creating this whole thing by itself is an action, right? Which is composed of smaller actions or sub-actions. So in this case, when I run this higher level action, you see a whole bunch of activation IDs at the bottom here. And the reason being, each of the sub-actions may be called in the order that I specified based on that if clause in the composition. There's a tool called Whisk Deploy in Apache OpenWhisk, which you can use to create a state of your world or your actions in a YAML file, and then you can use this tool to deploy all of that at one time. We use this command here, right? We use this update and create command here, but you don't want to do that one at a time for every action. So this Whisk Deploy tool lets you do a batch deployment or update of your actions. And there is so much more to Apache OpenWhisk and in general to serverless as well, right? So we talked about some of these. We haven't looked at API Gateway. The workshop we'll go through that. Again, web actions, what does that mean when you set web equals true? We'll look at that as well. We'll look at how to install external packages. So if you're using Node.js, you might want to use some NPM package which is not present in the IBM runtime. How do you do that? How do you debug locally? There is a way to get a version of OpenWhisk completely running on your laptop as a jar file, which makes things like testing and CI/CD really easier than it is right now. So we'll look at that as well. But in the meantime, if you want to play around a little bit more with OpenWhisk and get some help, here are some links that you can go to. So they have a wonderful team on Slack that answers questions very quickly. If you have any beginner level questions or more advanced questions, please go there and ask. They have a good set of docs. They're present on social, so YouTube, Medium, Twitter. The last one is the most interesting to me. So if you're really getting into OpenWhisk, you can attend these bi-weekly inter-exchange meetings. And this is where the contributors and the core architects and anybody else in the general community who wants to join can join and present ideas, or I feel just going there and listening into what's going on is very helpful for me to learn about OpenWhisk. So hopefully that gives you some idea. There's also some cool tooling around OpenWhisk. So one of the ones that stands out for me is this thing called Kui Shell. And it's essentially, actually I have it running here. If I were to upload it or bring it up, I can do everything we did before. So I can say action list, etc., works just fine. But then it has this grid functionality, as you can see here. We created these two actions today, and it tells me how long it takes to run. And then if I go into any one of those, I can look at, there were no logs generated, but I can look at logs and results and things like that, right? So pretty cool. Also lets you visualize sequences that we talked about in composing actions, okay? And here are some things to consider, right? So first thing, like I said, functions are generally stateless. So you as a developer need to, you're responsible for persisting state between runs, right? When you pick a serverless platform, your basics of coding and developing application doesn't go away. You still need to be able to test locally, still might want to have a CI/CD pipeline before you push code to production. You still want to have some sort of way to version control your functions. How do you monitor your functions? Is there good logging available or not? And then this problem is interesting, the whole problem with cold, warm, and hot loads. So if you go back to this guy here, right? So let me do this grid thing one more time. As you can see, the first time it took 39 milliseconds and then 3 milliseconds. So the first one is a cold start. The second one, the container was already present and it reused a container. And then it goes from 3 to 1 to 4 to 42 milliseconds. So between these two, there's another cold start. So for my small hello world function, doesn't really matter, but might be a problem if you're running some critical code. And how do you get around that? This is just a fun slide. Kelsey Hightower, he's a big promoter of serverless and cloud native at Google, and he created this library called No Code. Essentially, the repository has no code. So this hopefully is not the future of serverless. We still need to write some code and deploy it on a serverless platform, but I just thought this was funny to show. Okay, with that, I think I've said everything I wanted to say, Brian. Again, this is my email and my Twitter handle. Please add me to your Twitter. I'll follow you back. And then also, if you have any questions, please let me know. I'm going to quickly go back and check for questions. Brian, I don't see any questions. So hopefully everything made sense, or maybe nothing made sense and people just dropped off and it was just me talking to myself.
Thanks for watching.